Kia ora Year 12, here's question 1E from 2014's integration paper. I'm just going back and filling in the gaps on external questions that I haven't done. So this one is one where we've got to find the area between two curves. We need to figure out the intersection points to do that. They're right here. They're going to be my limits of integration. And then we're going to find the integral of the top curve minus the bottom one and integrate with respect to x. So that's how the problem's going to go. So the first thing we need to do is figure out which curve is which. Well, this one here is the basic parabola, y equals px squared, and the other one is y squared equals px. Now, to find the limits, I've got two ways of doing it. I can either make y the subject of the formula here, and I'm going to do that now, because I'm going to need that to put it into here later on. So y is equal to the square root of the right-hand side, which is root px. I'm not interested in this branch down here, so that's why I haven't got a plus or minus here. So we can rewrite that as y equals root p times x to the 1/2. Okay, so that's the equation of this one here done. So what I have to do now is to find the intersection point, the x value where they're equal. So root p x to the 1/2 is equal to px squared. Now, what do I end up doing? Well, I'm pretty quickly going to square both sides, giving me px is equal to p squared x to the power of 4. Solving that requires me to go like this. So 0 will be p squared x to the power of 4 minus px. Factorising gives me px into px cubed. Let's see if I've missed anything out. Px cubed, take away 1. So either x is 0 or px cubed equals 1. X cubed is 1 over p, and x is equal to 1 over p to the power of 1/3. So that's good. I've got my limits of integration. Now I'm ready to evaluate the integral. So the integral will be from 1 over p to the 1/3 down to 0. What's next? The top function is root p x to the power of 1/2. Okay, that's the one that goes like that, minus the parabola, the up the usual way parabola, px squared dx. What does that give me? Well, I get root p, it's my constant, x to the power of 3 over 2 times 2/3 minus p over 3 x cubed. All I'm doing there is applying the power rule, and the next thing to do is to substitute in my limits. Remember, it's a show that question, so don't skip any little steps. Now, what do we get next? Well, substituting in, we'll have root p times 2/3, 1 over p to the 1/3 to the power of 3 over 2, minus p over 3 times that, minus 0 minus 0. Right, now we've just got a bit of cleanup to do. Root p times 2/3 times 1 over p to the power of 1/2. Right, sorting this out. And here we get p over 3 times 1 over p, since this is 1. Finally, we get root p over root p times 2/3 minus 1/3, which is 1/3 as required. Okay, so not too hard really, just be really careful when you're looking at the intersection points back up here. I think that's probably the hardest part of the problem. The rest is really year 10 or 11 algebra once you've done the power rule on the integration. So just carefully substituting in with fractional powers. Thanks for watching. I'll try and do the other ones later on this evening.